happen? Leads to partial electrical charge on atom represented by this one, sigma. Okay, right. So, or electronegative, electropositive, right? Electropositive or electronegative, right? So, such polar covalent bond can be depicted towards the negative pole by positive or electronegative symbol. So, this one H and Cl. H clearly is more electropositive compared to Cl. So, it has positive, okay, electropositivity symbol. This one it has electronegativity symbol. If you want to differentiate them using this symbol, or else we can differentiate them by using arrow. Put like this for electropositive, and then towards electronegative is in arrow. So in HH and Cl bonds, atoms are identical. So bond pair which is shared equally and non-polar covalent results. Okay, but if we have HCl, one would be in the poor region, electron poor region, and one would be in electron rich region. Okay, so this one electropositive have electron poor region, so it has electropositivity at this end, and then we have another electronegativity at this end. But this one we have electron rich. Why we call as electron rich? Because at this part we have more than 1. We have around 6 and 7. Satu kat sini yang dah share ni. Right, while hydrogen just have poor electron, it just have 1 electron. So they share electron, but this one has more electropositivity. Right. So this is a table of electronegativity and a common. So how do we know who is more electronegative than who? So look at this table. So across the period we have increasing electronegativity. So all the element in non-metal, basically they are more electronegative compared to this one. And then increasing from bottom to top, electronegativity will be increased. So meaning that this one is much more electropositive compared to this one. Alright, compared to lithium, for example, this is more electronegative. But when we compare these two, hydrogen and C and N, for example, and N lah. Okay, so hydrogen is much more electropositive compared to N, which is much more electronegative. Okay, that's it for example. Okay. So these are the trend where you can look at the trend how electronegativity is increased according to atomic activity. Okay. So based on that, based on the electronegativity difference, we can range the classifier of ionic character of their chemical bond. Okay, so let's say when we have no differentiate between the electronegativity, which is 0, that is known as non-polar covalent bond. Okay, if you have more than electronegativity is less than 2, that will be polar. Okay, that will be polar sini. 2, sini. 0. So less than 2 is the polar covalent. And then if we have more than 2, they will become more ionic. Okay, more ionic. So electron transfer. This is partial electron transfer only. This is they share their electron. So classify the following either ionic, polar, or covalence bond in this manner. Right. So cesium is 0.7, Cl is 3, so this is much more electronegative compared to this one. So what kind of this? Of course, ionic. Alright, so we can compare between this one, Cs and Cl, and also we can find the differentiate. Okay, differentiate of their electronegativity difference, so that will give more than 2 is ionic. Okay, so now we have hydrogen and S. S is 2.5, S in this region, so S will be more electronegative. This is electropositive, so you minus these two, you got around 0.4. 0.4 is become polar covalent. Okay, polar covalent. Alright. So next is nitrogen, which is 3, and nitrogen. So they are equal. So when we minus, we got 0. So this is basically is covalent. They share the electron. So non-metal, they share the electron. They have no electron negativity difference. So that's why it has a covalent sharing. Metallic bond occur between metals, so it has electrostatic force, where we call it a sea of electrons. Alright. So normally metal, it has few properties such as metallic luster, malleable, where it can be hammered into thin sheet. Daripada tebal-tebal tu kita boleh ketuk hingga jadi nipis. It is ductile, can be pulled into wire. Okay, it has good conductor of heat and electricity, and it has high. So electron C model are packed so close with each other, valence electron become attracted to positive charge and become free from attractive force. The free electron delocalize over the solid results closed by ions embedded in the. So this is example of clouds, electron sea or electron clouds. So we have a lot of them. Okay, there are flow, there are what we call float into each other. They are not attracted to each other, but they are there. They exist as seed of the ion. Okay, look at this one. Give the correct type of the bonding. Cr alone, metallic. Okay, ClF covalent. This one covalent, and then we have ionic, and the last one is. Okay, so octet rules yang mana we follow simple rule of thumb that state that atom tend to combine in such way that they have 8 electron in the valence shell. Atom akan gain, loss or share the electron to obtain the octet. Okay, the same rule, the same number of valence electron as the noble gas closest to them in the periodic table. Octet normally consists full S or full P. Okay, or this one. When atoms form covalent bond, they tend to share the sufficient electrons so to achieve the outer shell having 8 electrons. This is indicate that all atoms in molecule are attached to one another. For example, noble gas. Noble gas like full octet and S2 and P6, it has 8 electrons. It has stable monoatomic gases and can form. This is octet rules. It works well with group 1 and group 2, with aluminium or with non-metal. Okay, but it does not works with this metal ni. Okay, this is transition metal. So hydrogen and helium can't obey the octet rule because it just has 1 to 2 electron only. So it limited to 2 electron in the shell. Okay, it doesn't work with transition metal and post-transition metal. So this is how we draw the Lewis structure. We have seen. Okay. Right, so diatomic gas like hydrogen and hydrogen, they are sharing. Okay, they are similar, so they are sharing, so they form covalent bond. And then fluorine and fluorine also sharing the electron, they form the covalent bond. Same thing, just to show you what is the diatomic gas is. H and F, okay, so they form the covalent bond as well to complete the octet. Okay. Many nonmetals form more than one covalent bond. For example, this one, carbon. Carbon has 4 electrons. It can form 4 bonds with hydrogen. Okay, 1, 2, 3, 4. Alright, so carbon is 4. It's sharing the electron with one of the hydrogen to form the CH4 methane. Okay, nitrogen is 5. You need 3 more electrons. So it can form 3 bonds. 1, 2, 3 with another, like with the hydrogen. And it have one lone pair here. Or we call it as dative. Alright. So oxygen needs 2 electrons to form 2 bonds because it has 6 now. It needs 2 more to become octet. So it can share with 2 hydrogen to become H2O. So it has 2 lone pair. 1, 2. Okay. So single bond. We have, alright. So double bond. We have C. Next. Example, how to draw Lewis structure of SiF4. Okay. First thing first, which one is much more electronegative? F4 much more electronegative. Si is least electronegative, so Si will become the center. So we predict the structure will be like this: Si, F4 like that. Okay, and then number 2, we count how many silica. How many silicon? So we have this one Si. 1 Si can form 4 electrons. So we write 1 times 4 electron to become 4 electron. And then we have 4 fluorine. 4 fluorine, satu fluorine ada 7 electrons can form. Okay, so 7 times 4 is equal to 28. So total electron now is 32. 32, we predict it has going to have single bond. So you minus each single bond has 2 electrons. So you minus 8. 4 darab 2, 8 8. So 32 minus 8 is equal to 24. 24, bilanglah how many remaining electron ni, ada 7. Setiap satu ni have 7. 7 times 4 is equal to 7 times 4 is equal to lone pair. So you count lone pair. So 6 setiap satu ni. 6, 2 here, 2 here, 2 here. Yang dah buat ikatan jangan kira. So you have 6. 6 times 4 is equal to 24. 24 minus 24 is equal to 0. So dia dah tak ada what we call lone pair. Okay. Alright. So how do we draw the Lewis structure? Lewis structure will be draw as this. So you have 6, you have the bonding, there is no lone pair, the silicon. So next, how to draw hydrogen carbonate. Hydrogen carbonate is as this. So hydrogen is much more electropositive compared to carbonate. Carbonate is C. C is much more least electronegative compared to oxygen. Oxygen yang paling electronegative. Alright, so carbonate adalah oxo ion. So C the center. O adalah O will be around H attached to another. Okay. So we predict the structure will be like this. Okay. Carbon, center ion. Okay. And then O and then H will be bonded at the end. Okay. So now we count. So carbon, 1 carbon times 4 electron, it can form 4 bond. 1, 2, 3, 4. Okay. 4 electron. And then we have oxygen. Oxygen ada 3. And then each of them having 6 electron. Okay. Then that will give to 18. 2 hydrogen, 2 times 1. Okay, that will give you 24. So how many single bond? 1, 2, 3, 4, 5. 5 times 2 is 10. So 24 minus 10 is equal to 14. And then how many lone pair? Lone pair of oxygen. So we have 6 here, 6 here, 4 here, 4 here. So 6, 4, 10, 10 plus 4, 14. So that's why equal to 10. Okay. But C only have 6 electron. So how do we do? We're going to have a dative. Alright. So that's why dapat macam ni. Okay. Right. Okay. 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 Because of too many electron, too few electron, we must convert one of the lone pair on O into the second bond to form the C. So that's why you have double bond here. So dia baru seimbang. Okay. N2F2, how we draw N2F2? We predict NNFF at the end. Okay, like that. Okay, and then we count. So N is 5. 5 electron times 2 is equal to 10. Fluorine is 7 electron times by 2 is equal to 14. Right, so then your total is 24 minus 1 to 3 bond times 2. So 6 electron remaining is 18. 18 minus lone pair F. 6 times 2, 12. 12 there, so it's equal to 6. So N electrons will be 6 as well. So minus 6 kat sini. Because nitrogen is 5. So minus 6, so we got 0 electrons. Okay, so now complete attack will become like that. Okay, alright. So because of this one, nitrogen is 3. Yes, nitrogen we have remaining 3 electrons kat sini. Alright. Okay. What do you think about this structure? It's so unbalanced, right? So what we need to do, we akan donate kat sini, kita donate kat sini, kita donate lagi to form. Yes. Then only it's stable. Okay? Then only it's stable. Right. Okay. So we stop here first, then we continue.